habit of writing what element is under what sort of stress, tensile or compression. If you're not sure, say you're not sure. It's fine, because there are some things that you have to look at thick wall, or you cannot assume that it's thick wall. When you go thin wall analysis, you have to think. Okay, fine. Okay, the difference between thick wall and thin wall is thick wall, you're not very concerned about the shear flow. Thin wall, you are very interested in the what? In the shear flow. That's the critical part. Okay, right. Okay, so we go from here. Okay, so we're going to write what will affect the normal stresses. The normal stresses is going to be affected by this, okay, by this, and this is not affected is because it's at the neutral axis. Okay, so we are going to do px. I think there's one more. Okay, so we're going to do stress x at element B, right? So this is going to be px divided by A, then plus by my over iyy multiplied by z. Hello?
Shouldn't that be pz?
Wait, pz. Wait, I'm looking at where. Oh yeah. pz. You're right. Let me draw my transformation. I think you're right. X, Y, right? Okay, so this is pz. Where are you? Orange juice or beer?
I'll take the orange juice.
Then my over iyy multiplied by z plus by mz over izz. Okay. So we know from the table the area. Let me see how much is the area. The area. You guys have the table, okay? I don't want to flip left and right to left. Okay, I don't want to make you guys crazy. So this will be equal to, the area is equal to, now I can't see my area because the words are so small. The area is 8 point. Let me look at the table. I'm done fishing. So the area is, hold on. The area is 5320 times 10 to the power minus 6, right? So the area is 5320. So this is equal to 5320 times 10 to the power minus 6. And we know the px is equal to 100 minus 100 times 10 to the power 3, right? And then if we were to look at moment about y, okay, so moment about y, right, is acting in a tensile manner. So moment about y, right? So this is moment about y, right? That is the direction. So it's going to be tension, right, plus by, I think I got this wrong also. Today is not a happening day for me. This is X, Eugene. Wake up. Okay, so this is mx over ixx multiplied by y. Okay, so that is minus 100 times, so area, so that's our axial load. So my, we are going to get a positive because it's in the tensile. So my is equal to 9600 divided by iyy. So iyy, again, I have to flip back to look for iyy, is 9.03 times 10 to the power minus 6. Okay, so 9.03 times 10 to the power minus 6. So now is the y direction, right? So y direction is this way, right? Y direction is this way. And sorry, we are looking at x direction. So x direction is this way, right? So the thickness of the web the thickness of the web. So if we look at the web now, okay, so the thickness of the web is 7.24, right? You can see down here is 7.24. So we go back there, 7.24 divided by 2. Okay, so 7.24 times 10 to the power minus 3 divided by 2. Okay, and then mx, okay, so moment about x, right? The y distance is 0, so this is equal to plus 0. Okay, so this will be equal to minus 100 power 3 divided by 5320 power minus 6. So it's equal to minus 18 with 100 power of 3. Okay, so 100 power 3 divided by 5320 power minus 6 is equal to 1.879 or 1.880 times 10 to the power 6. Let me try again. So 100 power 3 divided by 5320 power minus 6. 18 point, I think today I'm not right. So 100 power 3 divided by 5320 power minus 6. So this is equal to 18.797 times 10 to the power 6 plus by 9600 times by 7.24 power minus 3 divided by 2 divided by 9.03 power minus 6. 3.849 times 10 to the power 6. Let me do it again. 9600 times by 7.24 power minus 3 divided by 2 divided by 9.03 power minus 6 is equal to 3.849. So this will be equal to 18.796 power 6 plus 3.849 power 6. So this will be equal to 22.646 times 10 to the power 6 Pascal. Okay.
Is the 18 not negative?
18.
The 18.797.
Yes. No, it's positive. 18.79 is in Pascal. You're talking
Okay.
about this one, right? You're talking about
Yeah.
this, right?
Yeah, just
Right.
the never mind. Yeah.
It's negative.
Cole, you owe me an orange juice, Cole.
But it's negative 100,000.
Yeah. Oh, okay, okay. You mean, yeah, I know it's negative because it's compression. Okay, so minus. Yeah, I think this way.
So you owe me the orange juice.
No, Cole, I thought you talked about 18 times 10 to the power minus. Okay, I owe you the orange juice then. Let me tell you what, I'll upgrade into a beer.
Thank you. Sounds good.
Yeah. So this is minus 14.948 times 10 to the power 6 Pascal. Okay. So let me do it again. Okay. Now, what is, I don't think it's interesting, but what some solution manual does, which I've seen it before, they ignore this value. Why they ignore this value? Because they assume that B is exactly at the centroid. But if you've seen how B is drawn, okay, B is not exactly at the centroid. There's an offset of 7.24 times 10 to the power minus 3 divided by 2. Okay, so yeah, we have to include everything, or not you get confused, I get confused, everyone get confused. Okay. Okay, so the normal stress is always the easiest one. Okay, so now let's look at there's one that I'm not sure. Okay, so let's look at Vx. Okay, so let's go. So we are going to construct the shear flow for Vx now. Okay, we're going to construct. So I'm going to copy this. Okay. So today I'm being naughty. I've been skipping a lot of steps. Okay, so this is our Vx now. So Vx over here is sorry, don't mean to make those 22750. So we want to concentrate on element B now. Okay, so Vx is going this way. So if I were to construct the shear flow, right, how will it look like? Right, this is the one that I'm not sure. So we know that this is the main flow, the web controls the flow, right? So anyone, B is exactly down here, right? So from the upper flange, the shear flow will be coming down this way, and the lower flange will be coming this way, right? So what is so we're going to find again shear xz. So what were the QB for element B? Anyone? Hello? Anyone?
0.
Who are you? Where are you? Name, please.
That's me, Eugene.
Where?
It's Nathan.
Nathan. Spot bloody on. Miriam. Where are you?
Right here.
Yeah, can you see why is it equal to 0? What is the reason for it?
It's at the terminal.
Huh? No.
It's-
What is a better explanation? It's not just at the terminal. Remember what we say on Nathan. Why you say it's 0? Yes, Miriam, you first.
Is it the axis of the shear force thing?
No. But you're thinking about the tutorial that we did, right?
Yeah.
So Nathan, now to you, okay? Miriam has done a great part. Nathan, back to you. Why you say it's equal to 0?
Because like from the rules you use
Which rule?
whichever one says that you start it from the axis. So
It's not just that. Remember, we were solving this complex problem that is like I better not click on the wrong thing or not you will see the exam. I know some of you said, do it.
Sir, I was saying that.
Can you see this problem? Right? You have a reverse flow, right? Yes or no? You have reverse flow. So this section over here, right? This section over here has reverse flow. Yes, you have one flow coming in, one flow going, and it's into a terminal. Yes or no? So that is why this is equal to what? 0. Right? Remember we said we mentioned this, right? We mentioned that it cannot intersect. The flow has to be in one direction because now the centroid of concern is this centroid, the YY that we're interested. Yes or no? Why interested? Because we want to look at shear XZ is equal to shear ZX. This is equal to what? This is equal to VX over what? IYY AY, right? Divided by T. But the fact that they are both reason is on a terminal because both of them end at one point. They meet at one point, which classifies as a terminal, and the flow is what? The flow is reverse.
Professor, I have a
Yes.
question.
Huh?
I have a question.
I have no answer. No, come on. Talk to me.
So, would it be wrong if you were to write the arrows instead of going into the middle, coming out of the middle, and would Q still be 0 then?
Hello? So the shear flow is in the opposite direction.
Yeah. So like, can you like with the same shear flow in the webs? Can the shear flow in the flange be coming out? Would that still be correct?
Is this what you say, right?
Is that considered correct or not?
No, you have to answer me. Is that what you mean?
Yes.
Yes, it's still valid. It's still in reverse flow, yes or no?
Yeah.
So both are going opposite direction. There you go.
Yeah. Okay. Thank you.
Okay, Mustafa, there's more than one way to eat a hamburger, you cheeky sod. Okay, so
Yes,
that's why
sir.
I'm giving you a typical example what your term test will look like. Okay, it's very surface stuff. Okay, but I test you in a wide range. Okay, I don't go into depth. Okay, I test you in like any rules there is. Okay, you better know. Okay, right. Then the next one. Okay, the next one is going to be your wait. This one is straightforward. Okay. So this one is we are going to do based on Vy. So we are going to look at Vy now. Okay, okay, the shear stress. Yeah, shear stress. Oh shoot, I'm so late already. Shear stress from Vy. Okay, so again, this is your Vy. Okay, I'll make this quick. Okay, and then this is how your shear flow is going to move. Right. So for this case, here is your what? Here is your element B. So we know that element B will not be 0. Okay. So what I'm going to do now is I'm going to stop the lecture now. Okay. You guys already know how to construct the element. I'll continue to this example tomorrow during tutorial. Okay. I do apologize. I never knew that I went over time. Okay. I do apologize. So I'll still stay behind. I'll stop the lecture here. And I'll let you carry on to your other classes. Okay. Please accept my sincere apology for going over time. Okay. If that's the case, I'll end the lecture now. Thank you.